Test 1, 2, 3. All right, looks like the audio is working. Get started here in about 5 minutes. All right, it looks like it's 12 o'clock now. Can somebody give me a thumbs up or something to let me know that you can hear me? Okay, so it seems like you can hear me now. All right, we'll go ahead and get started. So what I'll do today is just show you some useful things that will help for Project 3. I won't be coding Project 3, but some of the things you need to know to successfully complete Project 3, I will go ahead and do. So for Project 3, basically what you have to do is you have to create a GUI, and you have to be able to draw, I believe, rectangles or ovals on that GUI, depending on what the user selects. So what I will show you how to do today is how to just draw a line. We will draw a line on the GUI, and then you should be able to take that and expand upon it and be able to do the rectangles and the ovals and the other things that you need to do. Okay, so we'll start with just our main method in our class main. I mean, you can call the class Project 3 or whatever you want to call it. I just call it main. All right, so not a lot of this, but a good portion of this is kind of a repeat from last week. So I will kind of go quickly through showing a GUI on the screen, and then I'll slow it down a little bit when it comes to drawing. So first, let's start our GUI. It's a JFrame, new JFrame. Okay, that's our window. JPanel will have a new JPanel as the main panel that all of our components will go on, and we'll add it to the frame. None of that has changed from what I showed you guys a couple weeks ago for Project 2. One thing we are going to add is this right here, panel set layout. There's different ways that you can lay out the GUI components on your screen. If you just add them without a layout, it'll add your components from left to right. If you do what I'm getting ready to show you, it'll add them top to bottom. I would just rather have my GUI components laid out like that. But there are a lot of different ways that you can automate laying out your GUI components. I'll leave the research to you to see if you want to do it a different way. But for me, I just want to lay out my GUI components top to bottom. So there's a new thing called box layout. It's going to take our panel and box layout dot. See, we can have y-axis, which will align it top to bottom, x-axis, which will align it left to right. So we want our components just to go from top to bottom. So that's our main panel. So what else do we need on here? Well, we need a way to put in, let's say, the coordinates for the line we want to draw, right? So if I want to have a numeric or text input, I can have a text field. Making a new text field. Let me set the size of it. Again, all this is just repeating from last week. 64 by 16. Just made up that's going to be the size of my text field in pixels. And then we'll add it to our main panel. Add the text field. Okay. Now we want to have a button that we can click, and when we click the button, I want it to draw the line that I told it to draw. So let's make a new button. New button. Put the text on it. Draw. We'll add a method to listen for when it is clicked. So this method right here gets called whenever the button is clicked. Let's add it to our panel. Add this button. And then that's enough for right now. So let's just test out what we have. So we'll have frame, just like we did a couple weeks ago, set default close operation, JFrame, X1 close. What that does is when I click the little X button in the top right of my GUI, I want to close the whole program. Frame.pack. What that does is it aligns the GUI components depending on what the layout is you have specified. And then frame.setVisible will show our window. So let's run that and see what happens. And it pops up on my other screen, so I'll have to drag it to the main screen over here. And so that's the GUI window that pops up. This is my text field, and that's my button. If I click the button right now, of course, nothing happens because I didn't put anything in this method to do whenever I click the button yet. All right, let's close it. So when I click this button, I'm going to have it draw a line for us. And so where do I want to draw the line from? Well, actually, if I open up the GUI again, I have this text field right here. What I'm going to do, I'm just going to type in the X and Y coordinates for the line that I want. For example, if I want to draw from the coordinate 2, 2 to 40, 40. What that means is the XY coordinate 2, 2, draw it to the XY coordinate 40, 40. That's just a straight line from one coordinate to another coordinate. Okay, so I need to kind of look at this layout. I have a number, space, number, space, number, space, right? I could just as easily do like commas, 2, 2, 40, 40 if I want, and that's just fine too. Well, we'll go with the commas. So this is our format, our layout. So let's put it right here off the corner of the screen. Let me move these out of the way. All right, so that's what our input will look like. So I somehow need to parse this 2, 2, 40, 40 into the X and Y coordinates, right? So we're going to have X1 equals something, Y1 equals something, X2 equals something, and Y2 equals something. X1 and Y1 are the first coordinate, X2 and Y2 will be the second coordinate. So what are they? Well, it's what I've typed in here. So first I need to get this information out of here. And we can do that as a string S equals, we'll use the text field variable, and we want to get the string in it, which is get text. And what that'll do, that'll get this entire 2, 2, 40, 40 as a string for us. So now we need to split that up into the 4 different numbers. Now you had to do this for, I think it was for project 2, where you were reading from a file and you had to split apart a string line into, what was it, pounds and ounces. So we need to split apart this line into these 4 different numbers. And we can do it I'm just going to call it parts. It's an array of these different parts of this. So we want to take our string, we want to split it, and we're going to split it at the commas, meaning we have a 2, 2, 40, 40. That means anytime there's a comma, it's going to split it apart into a new string. So this will give us an array of strings where the first one is 2, the second one is 2, the third one is 40, and the fourth one is 40. So what we can do now, we can now parse those out. I mean, this should be, what's it, parts 0, but we want an integer, and parts 0 is a string. So we need to take that string and convert it to an integer. We have integer.parseInt. There we go. So that'll take the first number in this string and convert it to an integer for us. And so on and so forth, except for now this one's 1, 2, the arrays, the indexes into the arrays. Okay. So now we have X and Y coordinates for a line. So just to make sure we're getting these right, let's just print them out to the console, system.out.println. Let's just print x1 plus space y1 space x2 space plus y2. This should just print out on our console the numbers that it read in. So let's run this and see how it works out. Over here. All right, so we've got a GUI. Let's just type in 1, 2, 3, 4. And click draw. Oh, for input string 2. I've done something wrong. Number format exception for input string 2. I'm not sure what I did wrong here. It's parts 1, splitting on the comma. Well, you get to see me do some debugging in real time here. Let's just print out this parts and see what it is, because I must have done something wrong in this split. All right, so let's put in 1, 2, 3, 4. Click the draw. That doesn't help me any. Let's print out everything in parts for int I equals 0, I less than parts dot length plus I. Now system.out.parts. That'll do. That'll go through the parts array and print out all the different parts. This was unexpected. All right. So let's do 1, 2, 3, 4. Draw button. You see it. Oh, it has that. That's what it is. So when we split on the string, excuse me, on the comma, right here in front of the 2 is a leading blank space, right? So the first split is just the number 1, and that worked fine. The second split is space 2. The third is space 3, and the fourth is space 4. Well, space 4 or space 2 or space 3 does not parse into an int. What we need to remove is all of that white space. We can actually do that. We don't need that print anymore. We can take it and we can do what's called strip. I think it's strip. Maybe that's C#. Let me see what it is real fast. Java remove leading white space. Oh, it's trim. Okay, yeah. Dot trim. What trim will do, it'll remove any white space at the beginning or the end of a string. So we'll do that. So now when we run it, we should get it printed out correctly where our numbers are appropriately parsed. Now let's try 1, 2, 3, 4. Click draw, and you see down here, print it out 1, 2, 3, 4, which was this right here. So now this right here is working. Where things can go wrong though is, what if I have invalid input? What if I put A, B, C, D, right, and draw? You know, I get this like nasty exception. So this is where you got to kind of handle some error, meaning we want to show some kind of error to the user if they put in something wrong. And how do we do that with exceptions? We have the good old try and catch, exception E. And if they have an exception, we'll just have a pop-up box that says you did something wrong. Okay, option pane, like I said, this is still stuff that we did a couple weeks ago. This is dialog box, panel, you have invalid input. We'll just pop that up if they do something wrong. So let's run it and make sure that's what happens. So we have this, 1, 2, 3. Even if we don't have all the numbers, click draw and you have an invalid input, A, B, C, G, whatever, invalid input. Well, if we put in right input, no problem. Okay, so now we got our input for the start and beginning points of a line. Okay, well now how do we draw the line? Now I'm probably going to give away more than I want to for the project, but it's what I got to do to show you how to draw. So we have all these GUI things, right? We have buttons, we have text fields, and we have panels. Now, if you look at your homework assignment, it says to make a panel or make a class called drawing and extend the J panel and draw on that, right? So let's make a new class. Let's call it, I'm just going to call it my panel. Right? It says you need to extend the J panel. So what does extend mean? And I'll cover subclassing here towards the end of the discussion. What does subclassing, what does extending mean? I know some of you have problems with it because I've seen, well, honestly, some of the stuff you've submitted and some of you don't quite understand subclassing. So what it means when you extend JPanel, that means my panel is a JPanel. It doesn't have a JPanel, it is a JPanel, meaning anything a JPanel can do, my panel can do the exact same thing. In my code anywhere, if I'm using a JPanel, I can replace it with a my panel and it'll work perfectly fine. Extends just means it has everything the exact same, but I want to extend it. I want to give it more functionality. And there's a couple things you have to do with the my panel. One is we want to set how big it should be, right? There's a method called override, what was it? Get preferred size. If you override that method, here's where you can set how big you want my panel to be. And it says it's a public method. It returns a dimension. So let's return a new dimension. And in here we can put the width and the height that we want it to be. I want it to be 400 by 400 pixels. That's how big I want my panel to be. All right. We'll come back to this in a minute. But so my panel is what I want to draw on. So let's add a my panel in here. So have my panel equals a new my panel. Let's add it to our frame, or excuse me, add it to our main panel. Add, let's call this a drawing panel, makes it more clear. So to the main panel, we want to add our drawing panel. All right, let's run this and see what it looks like. Here it is. So we have our text field, we have our button, and this is my panel. Right here, it's about 400 by 400 pixels in size. Okay. So now we need to figure out, how do I draw a line on here? And this was the whole point of subclassing it, is so that we can draw a line on the panel. There's another method, and your homework tells you to do this. It's called override, was it paint component? This method right here. What paint component does, any drawing operation you put in here, that is what will show up on your panel. Now you do not need to manually call this function. The Java framework knows to call this function automatically anytime that your panel needs to be redrawn. Hold on 1 second, let me send an email. Someone lost the link, because of course they did. Copy link, reply. Oops. Good thing I'm not limited to 40 minutes anymore. Sorry, I'm just trying to find the link so I can send it out. Okay, sorry for the interruption. All right, so in here, anything that we draw will show up on that panel. Well, fortunately for us, we have this handy little graphics object. And with that graphics object, you can do a lot of stuff. So it's this graphics G. If we just put G dot, it'll tell us everything we can do with it. We can draw a string, we can set color, we can draw a line, we can draw a 3D rectangle, we can draw characters, draw image, draw oval, hint, hint, draw rect, hint, hint, etc., right? But for my example, I just want to draw a line. So I can do g.drawLine and give it x1, y1, x2, y2. So for our example, let's just say I want to draw from 10, 10 to 300, 300. Let's just say I want to draw that line, right? Okay. Let's run it and see if it gets drawn. Sure enough, there's my line from 1010 to 300 300. So that's drawing a line. Now what I need to figure out is, how do I draw a line anywhere that the user inputs, right? If we go back over to our main, you know, the user inputted x1, y1, x2, y2. They inputted those variables, right? So somehow we need to tell this where to draw. So let's make a new method called draw the line. And what do we need to know to draw a line? We need to know the x1, the y1, x2, and y2, right? But the thing is, we'll come right back to that. So this is how we're going to draw our line, right? So whenever we click this draw button and we extract these numbers, we want it to draw that line, right? And we want to draw it on this drawing panel. I have to rearrange something real fast, because in here I want to use what? Drawing panel, right? But right now, since the program goes top to bottom, it doesn't know what drawing panel is yet. Drawing panel comes after it in the code. So let's just take this creation of the drawing panel and put it up here. That way the panel is already created, and so it knows what it is and it can use it. I still add it down here because I just want it to appear after the button. All right, so let's do a drawing panel. Draw our line from x1, y1, x2, y2. Okay. Let's run it. So let's put in, say, 5 to 150, 30. I don't know, right? Let's draw it. Thing is, the line didn't change. So why didn't it change? Let's look at our code. So we call the draw line, and we put it in here, but we don't do anything with these numbers, right? So how can we use these numbers to draw right here? We somehow got to save them, right? So if we have some class variables, x1, y1, x2, y2, whenever we call draw, let's save them. 1 equals x1, this x1, this dot y1 equals y1, this dot x2 equals x2, this dot y2 equals y2. So now we're saving these variables whenever we call the draw line with them. And then those are the ones we want to draw with. We don't want these hard-coded numbers in here anymore. X1, this dot y1, this dot x2, this dot y2. So now it'll draw from these coordinates to those coordinates, which I pass in with this draw line function, and I call that draw line function right here when I click the draw button. Let's run it. Here's our GUI. As you can see, there's no line drawn yet, and why is that? That's because right now all these numbers are equal to 0. Actually, it's probably drawn a little tiny dot right up here in the corner because it's drawing from 0, 0 to 0, 0, which is just a single dot. So when we click draw, oh, I have invalid input. So we want to draw from 10, 10 to 40, 50. Draw. Still not there. There's one thing we haven't done yet. So when I said you do not call this method directly, the Java framework knows to call this whenever it thinks your panel needs to be drawn, right? But when we call this draw line and we change these numbers and save them, Java itself doesn't know we want to redraw this whole thing. It doesn't understand the concept. It knows I'm saving numbers. It doesn't know what the numbers are for. So we need to tell it we want to redraw. And we do that with this dot, what was it? This dot repaint. We call this dot repaint. That forces that lets Java know that we want to redraw our panel, which will then in turn call the paint component, which will then in turn call this g.drawLine. Let's run that. Here we go. And it should draw a line this time. Let's draw from 10, 10 to 100, 300. Draw that, and there's our line. If we put in some invalid input here, draw, just says you have invalid input and doesn't do anything. We can change this, say 50-50 to 45-12, you know, whatever. Draw, and it changes our line. So that's 90% of your project right there, is taking the user input, clicking a draw button, and drawing onto a panel. Some of the other things you have to worry about for your project is you have to make sure it's not out of bounds. So when you draw something, you need to check and make sure it's within the bounds of the panel. And how big is the panel? So let's say if I wanted to check just the first coordinate, the x1 and y1. Well, let's just do the x1 and you can figure out the rest. Right? So to figure out if the x1 is within range, so I said if, so if x1 has to be greater than or equal to 0, right? Because if it's less than 0, then it's off the left side of the panel. It's in the negative range. Okay. Invalid or what? Out of bounds, right? Or if x1 is greater than or equal to the panel width, out of bounds, right? Now that's easy for, and then of course you would check the y components, and then you would check the other x component and y component as well to make sure they're not out of bounds. Now with a rectangle, if I was drawing a rectangle, you have to consider that if the entire rectangle or a portion of the rectangle is out of bounds. But that's how you can check out of bounds. And your the instructions say that you have to make a new exception and you have to throw that exception, right? So just make sure you follow and do that. Okay. One of the other things you have to do is your shape can be different colors. Well, that's really easy because g.setColor. Let's make our line red. Easy enough. Let's run it. Let's draw from 10, 10 to 400, 300, 250. Draw. And it's kind of hard to see on this monitor because the line's real thin, but it is a red line. So that's how you can set the color of whatever shape you want to draw. Okay. Let's see. And that's about all I have to show you for your project. There's another thing I want to cover a little bit more about the super and subclasses, and I'll cover those real fast to, I just guess, get you guys in the right mindset for that, because some of you have struggled with super and subclasses. But that's all for project 3 that I'm going to be showing. If you have specific questions about it, I'll take them after I go over this, the subclass stuff. But that should be mostly everything that you need in order to do project 3. All right. So the other thing I'll show you real fast is, I already deleted it. Okay. Super and subclasses. This will touch a little bit on what you did for the last project. So let's say we have a class automobile. Okay, so I have a class automobile. So what's some stuff it can have? It can have, let's say, the name of the automobile, the weight of the automobile, and the year it was made. Okay, just some things about an automobile. Let's make a constructor. I can take this information in. There we go. All right. I can take that information in and save it. And then let's just have a method called drive that will drive our car. But all we're going to do when we drive it is we're going to just print something out to the console. Let's say driving my, let's put the year, and then space, and then put the name. There's the weight in there too, but we just want to put driving my year and name of the car. Okay. So let's go back to main. I'm going to comment out all the GUI stuff because I'm done talking about GUI stuff right now. I just want to talk about subclasses, things like that. So comment all that out so it doesn't happen. So let's make an automobile. Automobile. It wants the name of it. Just call it auto. The weight 1, 2, 3, 4, 5, and the year 2005. All right. And then let's drive it. If I run this, it should just print out to the console, you know, this driving my year and name. Okay. Let's run it. Sure enough, driving my 2005 auto. Okay. Well, there are more specialized types of automobiles, right? So let's make another class, have an electric automobile. All right, let me do a split screen here on these, split vertically, so that we can see the automobile and the electric automobile at the same time. I misspelled it, but it's fine. So what does an electric automobile have? Well, it also has a name. It also has a weight. It also has a year. right? Electric automobile has all that. But it also has a range. Let's just say that's how many miles it can go on an electric charge. Okay, let's make a constructor for it. Name, the weight, the year, and the range. There, that's fine. So let's save all of it. Equals name, this dot weight equals weight, this dot year equals year, and this dot range equals range. Let's also take it driving. Drive system dot out dot println. So it's almost all this same stuff. But here I'm just going to put for this dot range miles. So it also tells us how many miles they can go. All right. So let's make an electric auto. Auto E, new electric auto. We'll call it E auto. It weighs 2, 3, 4, 5, 6. Its year is 2015, and the range it can go, say, 200 miles. All right, let's E.drive it. So what should happen here is it should make the electric auto and print out this information. Run it, and we have driving my 2005 auto, and then driving my 2015 E-auto for 200 miles. All right. So let's go back here. Instead of putting all this in drive, and you've seen a lot of this course so far, we have the toString object we've used a lot here, and we use that a lot to describe the automobile, right? So let's kind of do that here. Return, let's put all the stuff separated by space. Plus this dot weight, space, this dot year. Let's do something similar over here for my electric auto, except after year, I'll tack on this dot range. Okay. So so now that we have a string that describes it, here we can put driving my, and then let's just put this dot toString. So it'll construct this string out of the variables and just print it out here when you're driving. We'll do the same thing over here. Plus this dot string. All right, let's run that and see what happens. Okay, so driving my auto, weight, year, right? Driving my E-auto, name, weight, year, range. Okay. So what's the problem here? We have a lot of code that is completely duplicate of each other, right? Meaning automobile has name, weight, and year. Electric auto has name, weight, year. Here, the automobile is saving the name, weight, year. The electric auto is doing the same thing. The drive looks exactly the same now, right? System out println driving my this dot string. System out println driving this dot string, right? The toString is almost the same. This has name, weight, year. This one has name, weight, year, range. So there is so much here that overlaps that we don't want to have duplication of code like this. That coupled with the fact an electric automobile, it's an automobile, it's just a more specialized one. So that's when we want to use the extends automobile. That means electric automobile is an automobile, it just has more stuff. But what we have to get rid of out of here is the duplicate stuff. So this name, weight, and year, we want to delete it. And why? Hold on a second. Yeah. All right. One thing I didn't mention here, sorry, protected. When I have private that means only this class can access it. If I call it protected, it means that only this class or its subclasses can access it. Actually, we don't even need it. It can still be private. But that's good to remember about protected and private. Okay, so we have this electric automobile. It's a type of automobile. It still has all these same variables. You don't see them typed out here. But when we do extends automobile, it means it inherits these variables. Okay, so we have the constructor for electric automobile. We still need all the same information, but we also need to call the constructor on the superclass. And the superclass is just whatever the one is that you're extending. And you do the superclass constructor with the super keyword, and then you just put in there the variables for the class's constructor. So it's going to be name, weight, year, right? So we don't need these assignments anymore because we're doing them here in the super constructor. Only thing that we have new here is the range, and we have to save it. Likewise, let's assume these go away. We'll add one of those back in. You'll see why in a minute. Okay. So we have an electric automobile. It is an automobile, and it adds on a new variable called range. Everything else, it inherits from the automobile, which means it has a .drive method. It has a toString method. You don't have to add them here because they already inherited from the automobile class. So let's run this again now. And see, driving my auto, weight, year, driving my e-auto, weight, and year. What we're missing here is the range. And why is that? That's because we don't have our own toString method here. That means it uses the superclass's toString method, which means it uses this toString. So even if we have an electric auto, unless we specifically define a toString method here, it uses the superclass's toString method, which it only has the name, weight, and year. We can't add the range here because an automobile doesn't know what a range is. So we need to fix the electric automobile so that it adds the range into the toString. We can do that if we override the toString method. Right now, the default is just to return the superclass's toString. Really, that's going to be no different than what we already had because we're going to call the super toString, which is this method. It's going to make us a string that's name, weight, and year, and it's going to return that. So we still haven't added on the weight. The range. So what we can do is this portion right here, it is name, weight, year. We can just add on to it the range. So now when the toString method gets called on an electric automobile, it has a toString method. So it'll run this code. It'll get the super's toString, which is the name, weight, and year. It'll add on to it a space and a range. And then it'll display it. Let's click it and run it. And there we go. Driving my auto, weight, year. Driving my e-auto, weight, year, and range. Last thing I want to show you on it, and then I'll open it up for questions and answers. Let's say an electric auto drives differently than a normal automobile. So what would we have to do? As I said, if a method does not exist in electric auto, it'll use the method of the parent class, of the superclass. So because there's not a drive method in here, it uses this drive method, which means it just does drive like an automobile would. But let's say that for some reason electric auto did drive differently somehow. So we can override that drive method. So leaving it as it is right now, it'll just call the supers drive method, which it just calls the same thing, which is no different. But let's say we need to do something first. First, I don't know, it's a Tesla and I turn on the autopilot. So we can have system.out.println turning on autopilot. So we'll turn on the autopilot and then we'll drive it just like a normal automobile. So when I run this, when it has an electric automobile, it'll call the .drive method. It'll come in here and it'll print turn on autopilot, and then it'll do what is in the superclasses drive method, which just prints out the driving, my string. Let's run that. So if you look, this was just the normal auto driving my auto wait year. Now this is driving the e-auto, driving the electric auto, turning on autopilot, and then driving my e-auto wait year range. So that's how you relate a subclass to a superclass. You just got to remember that whatever is in the superclass, it is also in the electric automobile. The one hint I will give you how this applies to your homework is you have a shape, right? And it's supposed to extend a rectangle, right? Let's make a constructor for it. The reason why it's red squiggly is because each class is supposed to be in its own file, but I'm not going to run this code. It's just showing you an example, right? And so I've seen in the past people will do this. Rectangle, my rect, right? What is wrong with this? The thing is, shape, it is a rectangle. It does not need to have a rectangle as a variable, meaning people have done this before. My rect equals new rectangle and 1, 1, 30, 30 as the parameters for the rectangle, right? Well, what's wrong with this is completely incorrect, because shape is a rectangle. It does not have a rectangle. So get rid of that, because shape is a rectangle. Well, then how do we set the position of the shape? Well, rectangle is the superclass, right? We need to call the superclass constructor just like we did here. It's called the superclass constructor. And you can look up the documentation for a rectangle, but here's the ways you can initialize a rectangle. You can take another rectangle as a parameter. You can take the x, y, the width and the height. You can take the width and the height. You can take a point and a dimension, a point or a dimension. Those are all the different variables you could use. For me, I'm just going to put in the x, y, and the width and the height. Let's just say it's 1, 1, 50, 50. That's the rectangle, right? So now, this is the position and dimensions of the shape. That's because the shape is a rectangle, and this is the dimensions of that rectangle. So if we did something like this dot x, this dot y, width and height, it is inheriting all of these parameters from the rectangle. So if I wanted to draw this shape, I could do like, graphics dot draw rectangle, and then draw at the XY coordinate the width and the height. This is how the super and subclass thing applies to your project when you're talking about the different shapes. All right, so that's what I have to cover. I'm open to any question and answer you have. It can be related to Project 3 or not related to Project 3. If you can always email me directly for assistance if you want as well. I will respond to that. And just a reminder, the Project 3 is due Tuesday night by 11:30 p.m. Eastern Standard Time. Also keep in mind that you can submit any project late even projects you've already completed or projects that have already been graded. You can submit or resubmit any project up until the last day of class. However, there is a 5-point penalty per day up to a maximum of minus 15 points. So for example, if you scored really poorly, let's say you got a 50 on project 1, you could potentially resubmit it and get up to a max of 85, assuming you got everything right on the project. So it's a good way to boost your scores if you've done really poorly on a prior project. So I'll pause here, ask any questions you may have. If you don't have any questions, you can go ahead and tune out. I will post this video up online sometime later today. So please ask your questions. Yeah, also, if you just don't have any questions, you can feel free to drop off at any time, and you'll be able to watch the video later if you need to catch up on anything. It seems like everyone has checked off except for you, Martha. If you have any questions, let me know. If not, then I will wrap this up. Okay, sounds good. All right, have a good day.